Alrighty, watch the water wheel and observe. When I hold the hose low, the water wheel spins slowly. When I hold the hose high, it spins faster. So just like the height of the water is the pressure that's coming through the circuit, we kind of have the same thing going on here with this battery. So the height, which is the pressure, we call that voltage. So the more voltage something is, the higher the amount of pressure that's coming through. So just like that spinning turbine, we can put something on the bottom and we can put the pressure flowing through that, and it might be hard to see, but you can see that it's lighting that up. But if we increase the amount of voltage, which is basically just like lifting the hose up higher, we can do that by adding even more voltage. So that's just like lifting the hose up higher. And I've got this little wire, and I'll connect that in there, and just you can see that just like the lifting the hose up, it has increased the pressure of the circuit, and we're now doing, you know, more to the light, the same as the turbine was spinning faster. So the voltage is the pressure of the circuit. We have our hose and water is coming out, and we have our water wheel, and it is making that water wheel turn and then continues on down. So we already have figured out that the higher we make that hose, the more pressure it's going to come down to that water wheel, and the faster it's going to spin. So just like we had with those batteries, each one of those little blocks was 3 volts, and we call the bottom negative and the top positive. When I added a second one, we added another 3 volts, and those add together and now become 6 volts total. So with 3 volts of pressure, the little light bulb glowed dimly, but with 6 volts of pressure, the total of the 3 and the 3 together, 6 volts came down, and the light bulb, same light bulb, was now glowing brighter. And sort of explain a next sort of thing. So if we've got a large pipe and water is flowing through that pipe, well, we've got the pressure that's pushing that in, but we also have the amount of water that's flowing through, and those are actually 2 different things. So if we have a big pipe with low pressure, a lot of water can flow through. A big pipe with a lot of pressure, heaps of water can flow through. If we have a little pipe, then not anywhere near as much water can flow through. So we have the pressure and the flow, and in electric circuits it's exactly the same thing. We have the voltage, which is the pressure, and the current, which is the flow. So that is controlled by the resistance, which is essentially similar to the size of the pipe that we're putting it through. It doesn't quite work the same as like a bigger cable or a bigger wire doesn't sort of like change the total resistance at this point. It does later when we get to higher, like more complicated things, but for now just think of it in terms of the current flow. So we have the resistance, and that resistance is the light bulb itself. So that we have these 3 things that are all related to each other. Whoops. The voltage, the current, and the resistance. So you can see that you can't put a huge amount of current through a very tall pipe but you can put the same amount of voltage in either of these pipes. So the resistance essentially is stopping this current flow. It's stopping the amount of current flow. So the pressure can be the same in either of these, but the amount of flow can't be, and that is controlled by the resistance. But you can see that all of these are related to each other. We've got three things that are related here. We have the voltage, the current flow, and the resistance, and all of those things are related to each other. So what is the current? Well, when we're forcing that pressure through, we have tiny little pieces of atoms that are essentially breaking off and moving around the circuit, and those are called electrons. So originally the people who figured these things out, they didn't actually really understand what was happening fully. They'd kind of had some guesses, and so we call the positive charge conventional flow, but actually the electrons are flowing the other way. It makes no difference at this point what is actually happening on that level, but tiny electrons are moving through the circuit, and that's what's doing all of this thing. So current flow is actually the flow of these electrons through the circuit. Alright, so how is it moving through the circuit? So what we've got here is a massive wire, and you've probably seen a million of these everywhere. It's just exactly like the one I'm holding up here, but bigger, so you can see it better in the camera. So it's full of tiny little wires, all bundled together, and it's surrounded by some plastic. So those little wires in the middle, they're called conductors. And the thing about metals is that it's really easy for the electrons to flow through metals. So that could be copper, could be aluminium, could be steel, could be tungsten, it could be all kinds of things. But the conductors are almost always made out of metal, and the insulators are made out of something that doesn't have electrons flow through it very well. Some things like wood, things like plastic, things like glass, things like ceramic, they don't conduct the electrons and current flow very well at all. So this basically is how the electrons are moving, and this is sort of to stop them getting to places we don't want them to get to. Alright, I think probably the last basic point we want to get to here is that there is a relationship between the current flow and magnetism. So I think you can see it in this thing, but I've got this tiny little compass. So the Earth has got a massive magnetic field around it at all times, and this is able to align itself to the flow of that magnetic field as it sort of like goes around the Earth. But when you've got current flowing through a wire, that actually also, you can do this, you can, hopefully it's not like, yeah, you can kind of see that that is affecting the compass. Hopefully that is able to be seen on the camera there. You can see that, yeah, that the flow of those electrons through the conductor is creating a magnetic field. So there is a relationship between the magnetism, the electron flow, and movement. So I'll get into that maybe in the next video, but that's the whole basis of motors. If you have a conductor that's moving through a magnetic field, it will actually force the electrons to flow, and that's what's happening in a generator. If you have a electromagnet, basically a coil of wire with electrons flowing through it, it is creating a magnetic field, and it can be forced to move inside another magnetic field, and that's essentially the basis of a motor. And we can use that principle to do actual physical work and not just light up light bulbs. Alrighty, one more thing that I was going to add, put it back the way that it was before. If we have a circuit here and it's not connected all the way around in a loop, then it won't flow. So we have to have those, we have to have a closed circuit to make those electrons flow. So if at any point that circuit is broken, then it will stop working. So if we have this broken here, it'll stop working. If we have it broken up here, it'll stop working. So at any point that's not becomes a circle, then the circuit will not allow those electrons to flow around. And I think that's probably the basics. So if there's any questions, you can ask those. If anything becomes a bit confusing, just ask and I'll try to explain any bit of that in maybe a different way or a better way.